Thank you very much. Thanks for organizing the conference and sticking to the last session. So, as said before, I will present Flight from Urban Flight, Lead Poisoning, Crime and Suburbanization, and is joined with Federico from Madrid. So this will be a paper where we try to assess the effects of violent crime on the urban structure of a city, where people decide to live and where firms decide to locate. So, and there are two main contributions that the paper has. So the first one would be to present a new instrumental variable to predict violent crime. So we have seen a lot of IVs in these 2 days, and this would be another version of the similar methodology, but this will use difference in difference, a fuzzy difference methodology to create an instrumental variable. And this is something that will allow me to have randomization of violent crime around the US in this case, but it can be applied to many other countries, so it would be interesting to see if anybody's interested in doing this in Australia, for example. And then we use this randomization of violent crime around the US to see what are the effects on distribution inside the city of different things. One of them is people. So we will look at where people or forms are located inside the city due to violent crime changes. And then we will also ask ourselves if the people that are moving around the city due to violent crime are just a random subsample of the people that were living in the city, or there is sorting in this movement. So who are the people that are moving out? And it will end up being that it's not a random sample. The people that are escaping from violent crime are a specific subset of the population, and this will create segregation inside the city. So we will look at race and income, and also effects that will have on the urban infrastructure of a city. So so let me introduce a bit, maybe the less known part to criminologists of my paper. That would be the urban side of the paper. So what you need to know about the urbanization and cities in general is that there is a long-term trend of increasing urbanization in the world. So we passed the 50% mark of number of people living in cities with respect to rural areas, and this is just growing. And there is this other phenomenon going on that is suburbanization. So here, when I'm talking about suburbs, I'm using the American interpretation of suburbs. That means low density outside the city center, far away from the city center, places where people live, still in a city. And suburbanization is the phenomenon of people moving from city centers to these low-density urban areas outside, far away from the city center. And this is a phenomenon that is going on in different moments around the world. So in the case of the US, that's where I will study. It started in the 50s and 60s until at least the 90s. And for example, let's look at Philadelphia as an example of what is going on. Philadelphia, in this period of 30 years, lost 400,000 people from the city center. There used to be 2 million, now it's 1.6. The suburbs grew a lot, moving from 2.4 million to 3.5 million of people living in the suburbs. And there are different ways of measuring suburbanization. What I will use throughout all the talk will be the percentage of people living in the city center that you just divided two. And there was a drop in 14% of the people living in the city center in Philadelphia. This is quite similar to what happened in many other cities in the US, this drop of 14% in the city center. And this is not something that happened only in the US. In different moments, it happened in different places around the world. And even in developing countries, it's happening now, where even if population is growing incredibly and cities are growing incredibly, the city centers are losing density. Australia is not, is also suburbanization happening in Australia. For example, in the same period I was looking in Philadelphia, these are two maps of Sydney and Melbourne during changes in density population in the 80s, between the 80s and the 90s. And you see how close to the city center is where we are losing population. This is, blue means drop in density population, and red means increase. This is a phenomenon that is worldwide and moved millions of people around places inside a city. So why violent crime has anything to do with this? So crime is one of the reasons that we'll show that is why people are moving towards the suburbs. And the mechanism we have in mind is that violent crime increases in the city center. This will decrease the value of living in the city center, given everything else the same. This is what we call amenities. And because of that, people will move outside of the city center. And this is the kind of mechanism that we want to try to get in this paper. So how do we do it? So we look at the US data. And what the data that we have is the following. So on the left-hand side, we have our measure of suburbanization of a certain city. So for each city in the US, each metropolitan area in the US, there are more than 300 metropolitan areas in the US. For every year from the 60s until the 90s, we have the percentage of people living in the city center. This is what you have on the left-hand side. And we want to know what is the effect of violent crime in the city center of this city in a specific year on this percentage. And this is what violent crime in the city center, this thing here. This is the violent crime in the city center of a specific city M in a certain year T. And we would like to know what is the effect of changes in violent crime on changes in percentages of people living in the city center. And even having all this data is not so easy to get to this beta value that is the thing that we're really interested in. And so here is where it comes, the first contribution of our paper that is try to find an instrument for violent crime of a specific city in a specific moment. So why do we need this? So there are many endogeneity problems in this kind of analysis. One of them is reverse causality. What it means is that we may see violent crime going up and city centers losing population, but has nothing to do with violent crime affecting the population where the population lives, but it's actually that city centers are losing population, and that's why we observe crime going up. So that's the reverse causality argument. And there are many, many omitted variables that we can think of that affect both crime and where people decide where to live. One could be just economic opportunities. If jobs disappear from a city center, maybe violent crime goes up, and also people leave the city center, and has nothing to do with violent crime that people are moving around in different parts of the city or in different cities. So what do we do? So what we do is, this is the kind of the big part of the paper, is try to find an instrument for violent crime, and here is where the lead in the title comes from. So the two things that we do is use as a time variation. So the thing that will change through time in our sample between the 60s and the 90s is the national consumption in the US of lead used in gasoline. And you will see in a few slides why this is important. And then as a cross-sectional variation, so the difference between different cities will be that different cities have different terrain. And this terrain will have an effect on how lead interacts with human beings. And this is why we observe different violent crimes in different cities. And this is the variation that we'll use. So it may sound a bit strange, this slide. So let's try to find out why this makes sense, and I'm not just telling you some random facts. So why lead matters? So this is bullet point number one. Why do we care about why lead has any influence on violent crime? So here I'm borrowing on, first of all, some medical literature, and also in other disciplines it has been studied, the effects that lead may have on violent crime and aggressivity in general. And the reason that doctors say that lead may have an effect on violent crime is that it affects how the brain works. So it alters the formation of the brain. So if you have lead poisoning when you're a kid, alters the formation of the brain, and this will affect aggression and impulsivity. And there has been, with different techniques, try to find out the effect that lead has on different behaviors that kids and then adults may have later in life. Kevin has worked on this, for example. And so that's why, lead may have an effect in your adult life on your criminal activity. So just to provide some evidence on this, let me tell you about how lead enters in the bloodstream of small kids, and that's why they get poisoned. And there are many ways, there are many reasons why human beings use lead. The one that we will focus on, that is actually the main way that lead end up in the period that we study in the bloodstreams of kids, and is through what it used to be used as an additive in gasoline. So even in most of the countries in the world, this is no longer the case, but in the period that we study, lead was used as an additive in gasoline because of different reasons you may remember. Now we have gasoline without lead. That's because they used to be lead in most of the gasoline used around the world, and when cars use lead, it comes out of the car, and then it may end up in the soil, and then the dust in the soil may end up at home, and then kids get in contact with that, or maybe directly, you're walking in a busy street where cars are passing by, and the kid just breathe this lead, and that's how kids get in contact with lead. And why? So what do we think is kind of the link between this and violent crime? Is that cars emit lead at a certain moment. Kids, in different ways, get exposed to this lead, and this has to happen in the early ages. So this is what the medical literature says, that the exposure to lead has to happen in the first 2 years to really have an effect then on behavior observed even in adulthood. And then this is why when they're adults, we observe higher levels of crime for certain people that were lead poisoned respect to the ones that were not. So yeah, let me just show you some kind of a famous time series in the US, but it can be replicated in many countries around the world, for example, in Australia. And it's where, first of all, that this is the time series of violent crime in the US from the 60s to, well, the latest information I have at least. And we see a huge increase in violent crime from the 60s until 1991. So you have to read the lower horizontal axis to see when the violent crime is happening. And then what we would expect, if you believe the previous slides, is that if lead has generated some of this increase in violent crime, then it has to be the case that some years prior to this increase in violent crime, there has to be an increase in lead exposure of kids. And this is where this other graph comes from. So the red line is the time series of lead consumption in the US moved 19 years forward. So for reading the years of lead consumption, you have to go to the upper axis. So lead was very low in the Second World War period, and it started growing incredibly once cars become popular and cheap to buy for everybody. And then it dropped significantly after 72, 71. That's the last year that we see the peak of lead, and it goes down drastically after that when there is legislation banning the use of lead in different ways for different type of gasoline for cars and trucks and so on. So with this graph, I don't want to say that the reason why violent crime increased is because of lead. So I'm just saying these two things happen at the same time. This is the only thing I'm saying with this graph. We need to have what comes after, that is some cross-sectional variation, to actually try to find out the causal effect that lead has on crime. And this is where soil comes on. So what the chemical literature tells us is that when lead comes out of cars, most of it goes into the soil, and when we may ingest soil either because kids are directly playing on the ground, or because of dust, they just inhale dust, and the effect that lead has on the brain will depend on the type of soil lead has deposited on. And the reason is that if lead has deposited on some certain type of soils, the body is completely unable to get the lead from the soil, and it just passes through the body. Instead, under certain conditions of soil, lead will interact with the human body, and that's where you can get lead poisoning. And what the chemical literature says is that for neutral types of soil, so where the pH is the variation that we will use, for neutral type of soil, we'll have very low bioavailability of lead. So it means the human has difficulty getting in contact with the lead if the lead has been in contact with the soil where the soil has neutral pH. For other levels of pH, lead is very bioavailable to humans. So it means that whatever lead you ingest, if you're a kid, it will end up in your brain, and this will affect your brain formation. And so this is the variation that we use, because what will happen is that this common shock that happened to all cities in the US, all cities in the US were affected by the increase in lead consumption, will affect differently different cities. Some cities will have soil that is very neutral, so whatever lead has been expelled by cars didn't end up in the bodies of people, and whatever lead instead happened to fall on land that instead was highly acidic or basic, it will end up being caught up by the body of kids, and then in the future you may expect seeing increases in violent crime. And this is exactly what we will use. So this is what the first stage of where we try to predict violent crime in a certain city center of a certain city in a certain year. And this we will explain it with two things. First thing is this lead here. Sorry, this lead here. This means 19 years ago, how much lead there was in the US. This is everything that it means. And here, what I have in the second part is a certain, tell me the pH of your soil. And we want to find out which kind of function of the pH will have an effect on violent crime. So what you would expect, given if you believe my story, is that for very low and very high pH, so acidic or basic pH, you should see big effects of lead on violent crime. For very neutral soil, you should see low effects of lead on violent crime. And this is the variation that we use. So you can plot this function and do a bunch of tests on this, and then what we end up setting up is a much more simple, the most simple function that you can think of, that is divide the type of soil in soil that makes lead very bioavailable and soil that makes the lead very non-bioavailable. And what I will call good soil for the rest of the presentation is when the pH is between 6.8 and 7.7, and this is the pH of the soil that makes lead very little bioavailable. Everything else, everything else is what I will call bad soil and is soil that when the lead is there, it makes it very bioavailable. So if kids play with this soil and it has lead in it, they will become poisoned. Could you please click on the button that is called continuous function? I think this will make it very clear just visually what is going on. So these are all the types of soil that there are in US cities. They go from incredibly acidic until a pH equal to 8. And this is the effect that increasing lead had on violent crime. And the way of reading this figure is, first look at the numbers here. They're all positive. They go from 1 until 2. So it means, independently of which soil you had, increasing lead had an effect on violent crime. This is when lead was increasing, violent crime was increasing. But it was increasing much more if you have this type of soil than if you have this type of soil. And this is exactly the story I was telling you before. If you have a neutral soil, when lead is increasing, it should have a little effect on you on violent crime, and while instead it should have a big effect here. And this is the variation that we'll use. We'll have a common shock that happens to all cities in the US. Some were randomly assigned to have high violent crime and low violent crime because of the pH of the soil. And then we can study what is the effect of violent crime on different outcomes, because we have this random selection of cities that are affected by this common shock. So yeah, can you click on go back to first stage? Thank you very much. So is it clear? Yeah. Great. So this is how the first stage will look, where we have good soil or bad soil here. Each city will have a soil that is set in time. So you see there is no T here. You have your soil. Sydney has a certain soil. Melbourne has a certain soil. The only thing that will happen is that
as lead increases, some will be more or less affected when we're looking at violent crime. And this is exactly the variation that we use. And this is what is called fuzzy different diff in this case. So there are many things that we like about these instruments. First of all, it's both time varying and geographically varying. And I will show you they can increase both the incredible increase of violent crime in the US, but also the incredible decrease in violent crime in the US. So what you will observe in the data is that cities with low good soil and bad soil, they started from the same violent crime rate. As soon as lead arrived, they diverged. And then when lead was banned, they converged again. So now these cities have the similar violent crime, as they started at the end of the Second World War. And another very nice thing about this instrument is that it can be used, in any country in the world. There is nothing specific about the US about this. You just need how much lead, for example, you want to apply it to Australia, how much lead in Australia it has been consumed, how many, one proxy for how much lead there was and how many cars were going around. That's a very good proxy for that. And then you have to know what is the pH of the soil of different cities. And you can exogenously predict violent crime in a certain city in a certain moment with that variation. So there are a bunch of things that need to happen for this to be a good instrument. So one thing is that we need to convince you that without lead poisoning, these places will have the similar trends in whatever outcome we are interested in. For example, suburbanization is the outcome we are interested in here. And we show that these cities looks very similar until lead arrived. When lead arrived, they started diverging, and then they converged back again when lead was banned. Another thing that I think is even more complicated to prove, and we have done a lot of work on this, is what is called the exclusion restriction. So the only reason why violent crime, while lead will affect suburbanization is through violent crime. This is what we should prove you. So if lead affects something else that affects suburbanization, then this is not a good instrument. And here we do a lot of things. One thing that you may think of, okay, pH of the soil affects agricultural productivity for certain things, and this may affect labor opportunity in a certain city, and this will clearly affect violent crime. And we show that this is not the case, but there are many other things that may happen. But yeah, let's just go to the results that I think is the most interesting thing. So first column is what is the first stage. So the way of reading this number, this 3.3, is that if you compare a city with good soil and a city with bad soil, and you look at them in 1991, the city with good soil has 3.3 less crime every 10,000 people. So violent crimes. So I don't know if you remember the graph where I showed you the violent crime rate. It started from 3 violent crimes every 10,000. It went up to 13. Well, what it says is that this 13 is an average between places with good soil that started at 3 and ended up having maybe 11 crimes, and then places with bad soil that started at 3 and had 15 violent crimes. And this differential is the one that you're seeing in this table. And then we can use this as an instrument to find out the effect of violent crime on different things that we're interested in. In this particular paper, we're interested in where people live. And we see that violent crime decreases the number of people living in the city center and moves people out in the suburbs. So the column 3 is how many people live in the city center. Column 4 is how many people live in the suburbs. And we see people are just moving from the city center to the suburbs. And people are not changing cities. So the last column is I'm asking places that had an increase in violent crime. Do we see them losing population? And this is not the case. And so let me just give you an idea of how big the effect is. This is huge effect. Violent crime in the US has moved 26 million people from the city centers to the suburbs. So the population of Australia has moved out of the city centers because of violent crime. And I think I just want to kind of finish with a last message. There are different things that you can look at the effect of violent crime on different things. But I think seeing how many people moved around because of changes in violent crime really shows when we are trying to do kind of policy evaluation and see violent crime reduction, the cost-benefit analysis of some violent crime reduction policy. We should not forget that violent crime has also huge effects on people, that live around where violent crime happens. And this is clearly very important for people because they are deciding to move so many because of violent crime increases. And what you can do with these estimates is kind of try to do a back-of-envelope calculation of how much people value violent crime decreases, and this is up in the billions of dollars in the US. So violent crime has a huge effect on people's welfare, and that's why they decide to move around. That's all.
Thank you. Have we got any questions? Yes, down the front, Don.
I've always got a question. Just wondering, have there been any studies which have compared lead levels in offenders and non-offenders, controlling for age and location, or the lead level in the soil where they live?
So what I know on lead poisoning, so there is very little data on lead poisoning at the blood level. So for knowing how much lead somebody really has, you need to get like a blood sample. And there has been some studies at the so for example in schools. So they get blood samples from kids, and what it has been shown is that there is a correlation between lead poisoning in blood of kids and how aggressive behavior during classes of these kids. So this is what. But again, these are all correlations because there are many reasons why you may have more or less lead in your blood. So for example, one easy way of getting lead now in your bloodstream is by buy some toys from some countries that don't have regulation on what how to paint toys, and some paint has lead, and then when the kid eats it, and then clearly there are different parents buying these toys, and then we observe different outcomes for different reasons that potentially are not related to lead. So that's why we don't know.
Yeah, I guess I was just thinking that the analysis hinges on the assumption that there were variations in blood lead. I know you can't measure it directly.
Yeah.
It's interesting to see the coincidence of, lead in the atmosphere and violent crime, but of course some other factor may account for that.
Yeah, so that's why we are not only using time variation in it.
Yeah.
That would there will be many other things that happen during that time, but we're only using the differential effect that you may expect in different with different lands,
right.
with different types, and also we don't see effects in non-violent crimes.
Right.
That would be again in line with what the medical literature would say.
All right.
Sorry, I was just going to point out that in New South Wales there's been a study that showed studied kids in Broken Hill where there was a lead mine, and it showed that year 3 NAPLAN results varied from educational outcomes, in other words, varied from that town and a neighbouring town because of lead contamination. Mm-hmm. So I was also wondering if within city, a particular city, you had variations in soil type. Say for in Sydney, there was variations in soil type. Could you get much more fine-grained measures of violent crime?
Yeah. So there is also I know of other studies using mining towns, for example, and the results are consistent with what you're saying. One problem with these mining towns differ from other towns for many reasons that are not only lead. So that's why it's always difficult to interpret these results, but they are very consistent throughout different studies. So there is for sure something there in a way. And on the fine grain inside the city, so there is data. The pH level soil data is very, very fine grain. So in theory, you could use that. There is one concern about using fine grain geographical distribution of soil, and it's that dust seems to be very important to moving around lead in the city, and this is driven by winds, and people just walk and bring dust with their shoes. So in a way, the type of land that you have in the place where you live is not the only thing that matters for lead poisoning, and the type of soil that you have. So we haven't done it, and it may be possible, but I'm not sure how much it will work.
Okay. Thanks very much, Federico.
Thanks.